Hello everyone, welcome back to another wonderful tutorial class, and this is another section of this The Best Academy online. And please, we have a very great topic on board, which is probability. Today I'm going to show you things about probability, although we're looking at introduction to probabilities. And what you will do for me now, ensure you don't distract yourself by any means, because everything we'll be doing in this place is going to be very needful. So please don't skip any part of this video. If you know you have not subscribed to this channel, please try and do so. And please watch this video to the end. And in case there's anything you don't understand, you have the opportunity to watch it over and over again. Now, what is the meaning of probability? That's the first thing. Now, there is something you ought to know, which is what are we actually looking at? Now, what you are looking at in this topic is probability. Now, probability is the likelihood of an event. Something that is not certain to happen, that this thing might likely happen. That's what we call probability. The likelihood of what? Of an event. And we have to call the probability of a certain event. Now remember we said probability is the what? Is the likelihood of an event, that something may happen. Now, the probability of something that is certain, probability of a certain event is always equal to 1. Take note of that. Probability of something that is certain, that this thing must happen. So the probability of that thing is always equal to 1. Take note of that. So that means all questions in probability of things that are not certain will not be up to 1. Because if something is certain, probability of that thing must be equal to 1. Are we still together? Alright. Now, we have what we call probability of something happening, and then if something is going to happen, there is going to be another probability that it may not happen. Now, the probability of something will happen, we call it success. And the probability that it will not happen, we call it failure. Now, probability of success and plus that of failure is always equal to 1. Also take note of that. Probability of success and probability of failure is always equal to 1. Probability of success is that this thing will happen. Let's say if probability of success is 0.5, probability of failure will also be half, because if you join it together, it will become certainty. It's either we're going to have a success or you're going to have a failure. Anything in life is either it's going to be in this way or this way. It's either it's going to rain today or it will not rain. Any of the two is going to happen. So that's what we call success and failure. Just think about what we are doing now. Let's say, okay, it's either it's going to be something like a very sunny today, or it won't be. It won't be. I don't know if you are still following me. Alright. So the probability of success, we need to note it with P. Just one letter P. And that of failure, we need to note it with one letter Q. And if you add probability of success and that of failure, will be equal to what? Will be equal to 1. Now, if A denotes an event, now what is the meaning of event? An event is just a set of outcomes in an experiment. Let's say we are doing an experiment now. The experiment is picking all even numbers from 1 to 10. Picking all even numbers from 1 to 10. That's an event. Call it an event. That is the outcomes we are going to have. Even numbers. Collecting even what? Numbers. From set of numbers that are from 1 to what? 10. Now, if you have an event A, now the probability of having this event A, we call it probability of A. There's some more denoted with PI. Now, the probability of not having A, we denote it by PA prime. Think of this. So the probability of event A, the probability of not A. Now, probability of A and plus probability of not A must be 1. That's what I'm trying to tell you. Because probability of this thing will happen plus it will not happen must be equal that is called certainty. It's called certainty. So something that is certain is either it will happen or it will not. It's like it's either you are either good or something like, for example, now, if something is not good, it will be hot. It's either you are on this app or you are in this other app. So it's either this will happen or this will happen. So if you join it together, we call it certainties. So it's either we are going to have probability of A and probability of not A. So if you have probability of A plus probability of not A, it will be equal to 1. That's called certainties. We call it certainty. Certainty. Now, before we go into this topic properly, I'm just trying to explain some things. So remember, the probability of a certain event is equal to 1. Probability of success plus probability of failure is also equal to 1. Take note of those two things. The probability of something that is impossible. Take note of this. Probability of impossible event is also called event that is not possible. For example, now, I cannot jump out of this video to come and meet you where you are. Is it possible? Probability of impossible event is always equal to 0. Take note of that. Probability of event that is impossible is always equal to what? 0. Take note of that. It's still very, very important. Very, very, very important. So probability of a certain event is equal to 1. Probability of success plus failure is also equal to 1. But probability of impossible or event that can never happen is also equal to 0. Take note of these three things. Very, very important. Now, we are still going. We are still going. Now, definition of terms. We would like how to define some terms in the probability. Now, the first term is event, which I've already defined. Just a set of atoms in an experiment. Now, what we call sample space. Sample space. We denote it by X. We denote it by X. Sample space. Now, sample space is a set of all possible outcomes in an experiment. It's a set of all the possible outcomes in a what? In an experiment. Think about that. Sample space is a set of all the possible outcomes in and what? In an experiment. E.g., if a coin, two-sided coin, if a two-sided coin, or if a two-sided coin is tossed twice, what is the possible outcome? Or what is sample space? What is all possible outcomes you are going to have is called sample space. So, what is the all possible outcome you are going to have? If we toss a two-sided coin twice, like what possible outcome you are going to have? Say that both of them will show head and head. Two of them will show head and head. Or the first one will show head, while the other one will show tail. Or the first one will show tail, while the other one will show head. Or both of them will show tail. And listen to this. We cannot have head, and tail. We cannot throw a two-sided coin twice. Or throw two coins. One. Look at it. What are events that are the same? Equal events. For example now. Tossing one coin. One two-sided coin. Don't remember two-sided. This place is head, this other side is tail. Just one coin, just one. If you toss that coin once, is equal to tossing two coins. If you toss that coin twice, you toss one coin twice, is equal to tossing two coins once. Take note of that. Now, if you toss one coin 4 times, is equal to tossing 4 coins once. Take note of that. So those events are called equal events. Call it equal events. Equal events. So in this event, we are tossing one coin twice. So if you toss it the first time and the second time, either going to have head to show up, or what do we call sample space? All the possible outcomes of this event. All the possible outcomes of this event. So of this experiment, then we toss it if you toss it twice, you're going to have either head to show up, or head, the other second will show tail, or the first one will show tail, the other will show head, or both of them will show tail. This is what you're going to have. Or there's another thing. You cannot have head, tail if you toss a coin twice. Because this one is 3 times automatically. So So this event now is called impossible event in tossing a coin 2 times. That is impossible. You don't have to do like this. Take note of that. So this is sample space. If you toss a coin once, so the sample space will be how many possible outcomes? 1, 2, 3, 4. You have 4 possible outcomes. So another way to look for the sample space of an event is to just get the number of sides of that of what you are using for that experiment. Get the number of sides. Like for example now, a coin has 2 sides. Then raise to the number of tosses. For example now, if you toss a coin twice, it will be 2 raised to the power 2. Toss a coin 3 times, 3 raised to the power 3. Where n is the number of tosses. Number of toss. Number of toss. So how many times do you toss the coin? So you toss it like 3 times now, it will be 2 raised to the power 3. 8 events. You are going to have 8 outcomes. 8 outcomes. Now, event will now be what is the event of having 1 head. The event of having 1 head is this and this. There are 2 events of having 1 head. So we have 2. The event of having 1 head is equal to this and this. We have 2 events. We have 2 of having 1 head. The event of having no head, that is 0 head, is 1. That is, you're going to have 0 head. The event of having 2 heads, that is 2. Just 1, not 2. It's 1. Only this one is having 2 heads. No other one is having 2 heads again. So that's what we call event. Now, what is now probability? Mathematically, probability is event over sample space. Event over sample space. So if I ask you, what is the probability of having 1 head? To be the event, remember the event of having 1 head is 2. Event of having 0 head is 1. Only these have no head. The event of having 2 heads, is only this one is 1. So probability will not be event over sample space. What is the event? What is the probability of having 1 head? How many events having 1 head? 2. We have event of having 1 head over the sample space, which is 2 over what is sample space for? 1 over 2. The probability of having 2 heads. We toss a coin twice. Then, what is the probability of having 0 head? How many events have 0 head? Just 1. Event of having 0 head over the sample space, which is 1 over 4. What is the probability? What is the probability of having 2 heads? Event of having 2 heads over the sample space. How many events have only 1 event? Just 1 over 4. So this is how to calculate probability. It's a very simple thing. Very simple thing. Now, what about types of events? What about types of what? Events. What about types of events? What about types of events? Now, events, we said, is the what? Set of outcomes you get from an experiment. Just a set of outcomes from an experiment. While the set of all possible outcomes is called sample space. Now, events can be either independent or mutually exclusive. Now, mainly we have like 7 types of events. Now, I'll be discussing just few of them. Then you can research on others. What we call exhaustive events, like event that will take all the sample space you have. Event that will take all the sample space you have. What is the event of having 1, 0, and 2 heads? The event is exhaust all the sample space called exhaustive events. What we call let me start with what we call let's start with mutually exclusive event. Let's start with them. Number 1, types of events. Mutually exclusive events. Now, events are mutually exclusive if they cannot occur at the same time. Events are said to be what? Mutually exclusive if they cannot occur at the same time. You cannot be in US and UK at the same time. So event of being in US and UK at the same time is impossible event. That's one number 1. Number 2, you cannot be in Nigeria and be in Ghana at the same time. It's not possible. It's not possible. So event of being in Nigeria and Ghana at the same time is mutually exclusive. It's not possible. Take note of that. Now, we are still going. We are still going. We are still going. You cannot be doing statistics or you cannot be doing the topic probability. You cannot be reading probability now, and at that same time, you will be reading mathematics or physics at that same time. It's not possible. It's either you do this on the YouTube, you go back to the other one. At the same time, both subjects cannot be read. You cannot be in statistics class and be in biology class at the same time. It's not possible. So those events are called mutually exclusive. That's what we call them. Mutually exclusive because they cannot occur at the same time. They cannot what? Occur at the same time. Now, I will be explaining some of the laws we have in probability. What we call general addition law, what we call general multiplication law. Now, for mutually exclusive events, general multiplication law. Now, take note of this or and. Take note of these two things or and. Now, we use or in sum or addition law. Then we use and in multiplication law. So if A and B, or if AB are two events. If AB are two events, let's say two general events. A and B, probability of A and B, which is denoted as probability of A intersection B. Is how to denote it. A and B means A intersection B. Now, the probability of A intersection B for mutually exclusive events must be equal to 0. Why? Because it is impossible. Take note of that. A and B cannot come at the same time. So if you want to have A and B at the same time, if they are mutually exclusive, it is impossible. So probability of impossible events is equal to 0. So take note of that. Very, very, very important. Very, very, very important. But probability of A or B is not equal to 0. Probability of A or B. Probability of A or B is not equal to 0. This one is possible. So you need to know this one this way. Probability of A plus probability of B. Probability of B. So I'm going to do this one. This one is equal to 0 for mutually exclusive events. So for general addition rule, for general addition for addition first, let us do addition. We'll do addition. Now, for addition, we use or. For multiplication, we use and. Now, probability of A or B, we say it as probability of A union B. This is how to denote it. This one is set as probability of A union B, which is probability of A plus probability of what? B. For mutually exclusive only, that's how to quote it. Let me give you how to quote it generally, the general quotation. This probability of it must be equal to probability of A plus probability of B minus probability of A intersection B. This is how to quote the general addition law. Probability of A or B must be equal to probability of A plus probability of B minus probability of A and B. This is how to quote it generally. Now, for mutually exclusive events, if A and B cannot occur at the same time. So if A and B are impossible, that is, they are impossible events. If A and B are impossible events, it cannot occur at the same time. So we will take this away. That means it's mutually exclusive. We will take that away. That means this one is 0. It's not possible. Because we said for mutually exclusive, A and B is equal to 0. A and B is equal to 0. So from this addition rule, probability of A union B will be probability of A plus probability of what? B. That is all. For mutually exclusive events. For mutually exclusive events. Now let me just use one to explain. Let me check if I can use one to explain multiplication law. Multiplication law. Now for multiplication law, this one is for addition. For mutually exclusive event only. Now for multiplication law, mutually exclusive events. If events are mutually exclusive, if you multiply them, it will be 0 because both of them cannot occur at the same time. Just as we use all for addition, multiplication for multiplication, probability of, we call it A and B. That's what we do, A and B, which is always denoted by probability of A and that is intersection B will be 0. This multiplication of A and B will be 0 because A and B cannot occur at the same time. So probability of for mutually exclusive events, multiplication law does not work. Mutually exclusive events. Only addition law work. Now let's look at independent events and dependent events. Let's look at independent events and dependent events. Independent events. Now events events AB are said to be independent. If both of them can occur at the same time, or if the occurrence of one do not stop the occurrence of the other. So two events are said to be independent, if both of them can happen or occur at the same time. E.g., for example, the event of you attending a class will not stop your neighbor from attending that same class. So let's say Peter attends Stat 101 class. Paul attends that same Stat 101 class. The event of both of them attending that class is it mutually exclusive or independent? Because Peter attending will not stop John from attending it. So those were called independent events. Something that don't depend on the other. When one depends or don't depend on the other, we call it independent events. Now, mutually exclusive will stop the other one. It's not that the evil depend. No. You just stop it. That means both of them cannot happen at the same time. It's not possible. For example, if I want to hit a target, the probability of me hitting the target and the probability of you hitting that same target, it does not concern each other. So you can hit the target. For example, now, if let's say everybody can go to anywhere they like. The probability of me going to the market, the probability of you going to the market, don't have any business to do with each other. But the probability of you going to the market will stop the probability of you going to school. You cannot go to market and be in school at the same time. So I don't know if you can get the difference between mutually exclusive and independent events. There's something called dependent. Okay, let's look at addition and relation law. Now, for if A and B are independent events, because nobody will tell you this event is independent, you really want to think and check, can both of them occur at the same time? Then you know that whether they are independent or not. I'll be calling some questions now, you'll be seeing them. Now, for general addition law, all will be probability of A or B, which is probability of A union B will be equal to probability of A plus probability of B minus probability of what? A intersection B. This will now be active. So this will be addition law. Then from addition law and multiplication law will be probability of A and B, which is probability of A times probability of B. So this will be the general multiplication rule, this will be the general addition rule for independent events. But for mutually exclusive events, this multiplication law will not exist. But only this one exists, in which this one will not be part of it for mutually exclusive. So if I call an event you will be the one to know whether it is mutually exclusive or not. So it's your work and your responsibility to know if a particular event is mutually exclusive or independent. Now, let's look at something very important. Let's look at something very, very important. Dependent events. Dependent events. What is dependent events? Now, dependent events are said to be dependent on each other if the occurrence of one affects the occurrence of the other. If what? Occurrence of one affects the occurrence of what? Of the other. But we not necessarily stop it. We not stop it. We not stop it. But we just affect it. We just affect it. But now when I say, how many? We have 100% in our battery. Eh? I want to use to wash something. You want to use to wash something. So if we can use and the thing will be reduced to 40%. I can also use it, but the time in which I will spend, the thing may be affected. Like time may be affected. If we don't stop it, we will just affect it. For example, now let's say you have a bag filled with red balls and blue balls. Now let's say the total balls there was 50 before. If you pick one ball out and want to replace it, now the event of you picking one ball out will affect the sample space, in which to be reduced to 49. So if I go there to pick another one, those two events are dependent on each other because one will affect the other. If one is this over 50, the other will be that over 49. We affect, it will just affect the other one, but we don't stop it. We don't actually stop it. We call it dependent event. But for mutually exclusive, they cannot occur at the same time. This first one will just stop the other. But you are doing this one, cannot do that. Yeah? Cannot do that. It's not possible. Yeah? It's not possible. Cannot be baiting. Yeah? Cannot be baiting now. Yeah? And be walking on the road at the same time. You do that, but this person is you cannot be in your bathroom and be on the road at the same time. And I said that you are in your bathroom like this or on the road. And I think this. So let's look at this question. Please look at other types of events. It's very, very important. Because let's look at some questions now. And please, if I call a question, you really want to do whether it's mutually exclusive or not. The probability, question 1. Question 1. Probability of John attending class. The probability of John attending this class is 1/2. While the probability of Peter attending the same class, while the probability of Peter is nice for John, while the probability of Peter attending the same class is 1/4. That's for Peter. Calculate the probability of John or Peter attending the class. Calculate the probability of John or Peter attending the class. Calculate the probability of John or Peter attending the class. Also calculate the probability of John and Peter attending the class. Also calculate the probability of John and Peter attending the class. Solution. Probability of John and Peter attending the class will be probability of John interjection, probability of what? That of Peter. And once the expression on for general condition law, probability of what? John times probability of what? Peter. And what probability of John attending the class? 1/2 times what probability of Peter attending the class? 1/4. To give us 1 times 1, just use multiply this. 1 times 1, that is 1. 2 times 4, that is 8. 1/8. The probability of John and Peter attending the class. What about the probability of John or Peter attending the class? The probability of John or Peter attending the class will be probability of John or Peter, which is probability of John union Peter. That will be equal to. Now let us check. One will say, it is 0. Is this event, is it mutually exclusive or independent? Is it dependent? Probability, this one will have probability of attending, this one have probability of attending. Both of them can attend class. Both of them can attend class. Yeah, for John to attend class, you must stop Peter from attending class. Because it's just a class, anybody can attend. Probability of John attending class is the attending class. Both of them can attend. That's why this is effective. As it is impossible, something like Peter and John cannot attend class, they will say probability of John and Peter is 0 because both of them cannot attend class. And I say probability of John attending Statonal class is this, then probability of John attending let's say Biology class is this. What probability of Peter attending both class at the same time? It will be 0 because they are not attending both class at the same time. They are not attending biology class and statistics class at the same time. Yeah? So that's just that. So this one will be equal to probability of what? John plus probability of what? Peter minus probability of what? John and Peter. So that will give us probability of John is 1 over 2 plus probability of Peter is what? 1 over 4 minus both of them is 1 over 8. That will be equal to, let's see, the answer of this is 4 times 2 times 2 times 2 times 1 is 2 plus 1 minus 1 over what? 8. That will be 3 over 4 minus 1 over 8. So the ratio of this is 8 times 2 times 6, 3 is 6 minus 1. That will be 7 over 8. That will be 7 over 8. It's very high that one of them will attend class. The probability of one of them attending the class is either John or Peter. They can also ask you, what probability of one of them attending the class? Is either John will attend or Peter will attend. You also do this. What probability of both of them? It is John and Peter. In this way. Both. That is both of them. This and this attending. One of them, this or this. And then you can get it. So you can see the question after you say, what probability of one of them attending? What probability of both of them attending? One of them attending is either this or this. You use an additional rule. Now both of them attending is either this and it's not even either this and this because both of them. We're going to do this one and this other one. So that's how we rule here. So we're going to look at some other questions here. Before we go, we are still here. Next question. Obtain the probability of getting an even number. Obtain probability of getting an even number. Obtain probability of obtaining an even number from a set of integers between 1 to 10. A set of integers between 1 to 10, both inclusive. From a set of integers between 1 to 10, both inclusive. The set of the sample space will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the sample space is equal to 10. We have 10 possible outcomes here. Now, what about the even? Even numbers are these 2 false. Number 2 can divide exactly. We have 1, 2, 3, 4, 5. We have 5 even numbers here. The probability of having even number will now be the event, which is 5 over the sample space, which is 10, and equal to 1 over 2. So that's the event, that's the probability of having an even number between numbers from 1 to what? To 10, both inclusive. Now, we have other questions. Question 2. If a 6-sided dice, if a 6-sided dice, if a 6-sided dice is tossed once, if a 6-sided dice is tossed once, obtain the probability of having, number 1, even number, of having even numbers. Number 2, odd numbers. Number 3, prime numbers. Prime numbers. Number 4, a 3. A 3. Obtain probability of having a 3. Obtain probability of having a 3. Then next, obtain probability of having a 4 or a 5. Obtain probability of having 4 or 5. A 4 or 5. Obtain probability of having a 4 or 5. The probability of having a 4 or what? Or 5. Solution. Now, the sample space is, if you toss a 6-sided die once, the other will have 1, or you have 2, or you have 3, or you have 4, or you have 5, or you have 6. Any of these will come up. But 6, you have 6 sides in this die you're talking about. One side have 1, the other is labeled 2, 2 is labeled 3. You have 1, 2, 3, 4, 5. They have different labels. If you have seen a die before, you have 1 here, 2 here, 3 here, 4 here, 2 here. Let the 6th side. It's labeled this one. So the number of sides we have 1, 2, 3, 4, 5, 6. We have 6 sides. And these are the possible outcomes you can ever. The possible outcomes you can have are what you are seeing here. The possible outcomes you can have. Now, what will be the probability of having even number? What will be the events of even number divided by sample space? How many events? 1, 2, 3. Even numbers, we have 3 even numbers here. 1, 2, 3. Numbers 2 can divide exactly. Divided by the sample space, which is we have 3 here, 1, 3 here, 2. 1 over 3, 2. That is the event of having even number. That is the probability of having even number. Now let's look at the probability of having odd number. Odd numbers are numbers who cannot divide. 1, 2, 3. 3 over 6, which is 1 over 2. Now what probability of having prime number? Prime numbers are numbers with 2 factors that only 2 can divide, with 2 factors, which is the number and 1. That is the only number that can divide this number I'm talking about. That's what we call prime number. The number that can be divided by just 2 numbers. Number can be divided by just 2 numbers is 1 and itself. These numbers are just 1 and itself, with a section from 1 exclusive. So how many numbers can divide 2? 1 and 2. So this is the prime number. How many numbers can divide 3? 1 and 3. Prime number. How many numbers can divide 4? 1 can divide 4, 2 can divide 4, 3 can, no, it's not. The how many numbers can divide 5? 1 and 5, the prime number. How many numbers can divide 6? 1, 2, 3 and 6, not the prime number. Yes, the prime number. So prime number have 1, 2, 3. So we have 3. For example, we 6. That was 1 over 2 as well. 1 over 2 as well. Then what about the probability of having a 3? How many events show 3 here? We have just 1 event showing 3. So the event showing 3 is 1 event over sample space here. Now what about probability of having a 4 or a 5? That would be probability of 4 plus probability of 5 with the addition of. Then if you say my probability of 4 and 5. Now look at it. Look at it. Look at it. This one supposed to be from general addition rule. You know the probability of 4, the probability of 5, my probability of 4 and 5. Now 4 and 5 cannot occur at the same time in this experiment. They are mutually exclusive. If you toss a die once, you cannot have 4 and 5 showing up at the same time. It's not possible. That's for impossible event. So that one will not show. You cannot have, suppose the probability of 4 and 5. This one is not possible. Because 4 and 5 cannot occur at the same time. So what we are going to have probability of 4, which is 1 over. What is the probability of having a 4? Just only 1 event showing 4. So divided by sample space 6. What is the probability of having a 5? Just 1 event showing a 5. 1 over 6. Then this one is impossible. That will give us 2 over 6. This 1 over 3. Probability of having a 4 or a 5. Probability of having a 4 or a 5. So we are still going. More questions are still coming. Alright, next question. A deck contains 52 cards. A deck contains 52 cards. You have 52 cards on the desk, of which 4 are aces. 4 are aces and 4 are kings. 4 are kings. 4 are kings. A deck contains 52 cards, of which 4 are aces and 4 are kings. If a card is drawn at random, what is the probability that is either an ace or a king? What the probability is that is either an ace or a king? Now, the sample space is that the total number of cards there is 52. We have 52 cards. And we have probability of 8 is there. The normal case is there 4 8s. And kings, we have 4 kings. So the probability of drawing an 8 or a king will be probability of 8 plus probability of what? Kings. You know. Now, remember, from general addition rule, suppose to say my probability of ace and king. Now, if you draw a card, remember you are drawing one card. If you want to draw one card out, you cannot draw ace and king at the same time. It's not possible. So now you will draw an ace or you draw a king. That is why this and this will not occur. Yeah, it's not possible for this and this to occur at the same time. So this will be equal to what probability of drawing an ace. The event of an ace divided by the total sample space plus what probability of drawing a king. The event over what? The total. So this is going to give us, you are going to do this, you just say 4 plus 4. That gives us 8. Then you pick one of the base over 52. 8 over 52. That's what I'm going to have here. Or let's check. 2 here, we have 4. 2 into 52. 2 into 52. We have 2 here, we have 2 into 12. We have 6, 26. So we can still go. 2 here, we have 2. 2 here, 1. 2 here, we have 2. So we're going to have 2 over 13. 2 over 13 as our answer. If we are going to drawing an ace or a king. Look at another question. On the same plate, the same way. Almost the same thing. The same thing. If 2 cards are drawn, if two cards are drawn from a well shuffled, we shuffle a card, we well shuffled cards. We well shuffled 52 cards. If 2 cards are drawn, we well shuffled 52 cards. What is the probability that both are aces? What is the probability that both are what? Aces. Now, if I'm drawing 2 cards, you can draw 8 and 8 at the same time. It's mentioned. But probably that both of them are aces. So this one is possible now to draw 8 and 8. We are drawing 2 times. So remember, we have in a deck of 52 cards, we have 4 aces. So 8 are 4 cards there. Now, look at the question very well. Let me put it in this way. In a where, okay, if you have 52 cards, you have 52 cards, what is the probability of drawing? Okay, if 2 cards are drawn, we well shuffled 52 cards, what is the probability that both are aces? If they are drawn without replacement. If they are what? Drawn without replacement. This one is dependent. They have a condition. What we call it conditional probability. If you draw an ace, you have you draw probability of drawing the first ace, the first one, before over the total. Now if you don't replace now, how many H will this is the first one? The second one will be, we have just 3 left because we have already removed 1. We have 3 H's left. Then the total number left will be now, probability of drawing the second H will be 3 over 52. The probability of drawing the second H. Though it's not 3 over 51 because 1 have left, so it will be 51. We don't replace it back. So the condition for this question is that these 2 cards are drawn from these 52 cards without replacement. So if you draw 1 out, 51 will be left. If you draw 1 ace out, 3 ace will be left. So if you carry another ace now, in where we have total 51 and 3 ace, and that one is an ace, the probability will now be the 8 over the total is 3 over 51. Try to understand that. It's very, very simple. So probability of both are 8. So that you're going to have 8 in the first one, and you still have 8 in the second one. You have 8 in the second one. That is probability of A1 times probability of A2. This one is not all, this one is and. You're going to have 2. So that this and this. It's not anywhere that. You're going to have 8 and 8. Aces. So what is the probability of the first one? 4 over 52. So I probability of 1 3 over what? 51. So if you multiply this one, you're going to have 1 over 2, 2, 1. That's what you're going to have 1 over 2, 2, 1. So that's the probability of drawing an aces if you draw 2 cards from the well shuffled card without replacement. That's the probability. Now let's look at another question. Another very important question. Now, a bag contains 5 red balls. A bag contains 5 red balls, comma. A bag contains 5 red balls, 3 white balls, and 3 white balls, and 4 blue balls, and 4 blue balls. A bag contains 5 red balls, 3 white balls, and 4 blue balls. If a ball is drawn at random, what is the probability that it is not red? What is the probability that it is not red? The ball is not red. What is the probability of that? The ball is not red. Now remember, look at what we are looking at. Look at, I told you before that probability of A and not A must be equal to what? 1. Started from that place. So remember, what is sample space here? We have 5 plus 3 plus 4. 5 plus 4. We have, and total balls is what? We have 9, 12 balls. We have 12 balls. There's that balls we have in there. Now, first thing, what is the probability of having red ball? To be, how many red balls we have? 5 over the total is what? 12. That is the probability of having red balls. The probability of having red balls. Now, what is the probability of not red? That is red prime. That is not red. You know what I mean? Probability of not red. That is the name. Means arrow prime. That is the probability of not red. Remember I told you probability of red plus probability of not red must be equal to 1. Remember I told you when we were starting this class. So from there we can find not red. Probability of not red will be 1 minus probability of red. Probability of red. So we have probability of not red will be equal to 1 minus probability of red. So from here we are going to have probability of not red, that is arrow prime, equal to 1 minus probability of red, is 5 over 12. That will be equal to, okay, that's over 1, that's 12. That's 12 minus 5. That will be 7 over 12. 7 over, okay, let's check. 12 minus 5, no, let's not say, it's 7. 12 minus 5 is 7. Yeah, over 5. So, probability of not red is 7 over 5. You are able to use, what are the balls that are not red here? You have this and this. The 2 balls that are not red. Probability of not red is, probability of both of them, you add it together, which is 3 over 12 plus 4 over 12 to give you 7 over 12. So let's have to do that question. So let's start another question. Last one. Last question. Last question for the day. Last question for me. Now, a bag contains 7 red balls. A bag contains 7 red balls, 3 white balls, and 5 blue balls. And 5 blue balls. And 5 blue balls. And 5 blue balls. If a ball is drawn at random from the bag, if a ball is drawn at random from the bag, just a ball, what with replacement? You are not draw a ball with replacement set. You draw it, you don't need to replace it, you are just drawing one ball. What is the probability that is either is red ball and blue ball? What probability of obtaining red ball and blue ball? If a ball is drawn at random, what probability of obtaining a red ball and a blue ball? If you draw one ball, we are drawing one ball. We cannot draw one ball to obtain red ball and blue ball. So the probability of obtaining red and blue by drawing just one ball is not possible. It's 0. Now, but if I say if 2 balls are drawn at random with replacement, if 2 balls are drawn at random with replacement, if 2 balls are drawn at random with replacement, what is the probability that we are going to obtain red ball and blue ball? The probability that they are red and blue, with replacement to red and blue. So the probability of drawing the red ball, or what is the sample space? The sample space is this plus this plus this, that's 15, is the total 7 numbers over 15. Probability of drawing a blue ball is 5 over 15. Now, what is the probability of drawing white ball? The probability of drawing white ball is what? 3 over 15. That's the specific probabilities. Now, the probability of obtaining red and blue, if you draw 2 balls, rather, the probability of drawing red and blue will be equal to probability of red times probability of blue. So that will be equal to probability of red is 7 over 15 times probability of blue is 5 over 15. 5 here 1, 5 here 3. So we're going to have 7 over 3 times 15, we will have 45. 7 over 45. That's what we're going to have. 7 over 45. Now, what about the questions like this? Let's say we have if 2 balls are drawn at random without replacement. If 2 balls are drawn at random without replacement, what is the probability that they are blue and white in that order? What is the probability that they are blue and white in that order? You draw 2 balls without replacement. Now, you draw blue. You draw blue ball. You're going to have total number of blue over sample space. Then you draw white in where you already drawn blue. It's a conditional probability without replacement. So white you still have 3 white balls there. But we have drawn 1 out of the sample space. Sample space will reduce to 14. So we now have total number of white divided by the new sample space now will now be 14 because 1 ball has already been drawn out without replacement. Probability of drawing blue and white will now be probability of blue times probability of white in where you have already drawn blue. Look like this. Where you have already drawn your blue out. So we usually like this way. So that will be equal to the probability of blue and probability of white in where blue have already been drawn. Where blue have already been drawn. So that will be equal to 5 over 15 times 3 over 14. So 3 here, 1. 3 into 15, that's 5. 3 into 15 is 5. Although we are able to do 5 over 15. How about you? Can we reduce down to 1 over 3 self? So that was 1. That was 1 over 14. That's what we have 1 over 14. 1 over 14. That's what we are going to have. So we are going to have. So please ensure you study this topic well. Go back and watch this video from the beginning to the end again. You have to get the topic very well. So thank you all. See you guys in the next class. God bless you.